So I will start the recording. So see, what we did in the last lecture is basically we did some iterative methods. So first one is what we did is the Newton method, Newton iteration method. Here what we are actually trying to find is the points x such that f of x is equal to 0. Okay. And second, what we did is some optimization problem. Especially we did something about the convex functions. Okay. And then we talked about the antiderivatives, and then integrals. So we talked about integral as area, and then we see what is the relation between these two, which are the fundamental theorems of calculus. So these are the things we have seen. So we'll do some problems which are related to this. So let's start with the Newton method. So the Newton method says the following. So what you want to find is you want to find point x such that f of x is equal to 0. Okay. Instead, what you do is you start with the point x1, and then you iteratively use this formula. And what happens is most of this xn will converges to some point x. Okay, so you have this xn's, and if you keep find the xn's, and they eventually goes to some point, let's say x, and that point x has the property that f of x is 0, or in some sense it goes closer and closer to 0. Okay. But one thing you can quickly observe here is here we have this f prime of xn in the denominator, right? So that one has to taken care of. If your f prime of xn became 0, then you cannot find the xn plus 1. In that case, what you do is you change this whatever the x naught you start with. So this is your starting point. This you just change it a little bit, and then you apply the method again. Okay. There may comes a time that this can be 0, but whenever if such a thing happens, you just change whatever the x naught you start with. Maybe put x naught plus some a, maybe change it a little bit, and then you can continue. Okay, so let's move on to the problems now. So here the problem is you have to use the Newton method to find the solution of the following equation. So you have a quadratic equation, and basically you start with this point x naught. Okay, so you have the function f of x. So this is your function f of x, and you have the starting point. Now you want to find what is the x2. You just use the Newton method and then find the x2. Okay. Maybe I'll just copy this. So you can remember this xn. So maybe I will change the orientation of this. This might help me to write a little bit more. Maybe I'll change the color also. Okay. So let's compute this thing. So first we have to compute what is the f prime of x. Yeah. So let's compute the f prime of x. F prime of x is you have the f of x here, and then you take the derivative of that. That will be 2x plus 1. And that is your f prime of x. Now let's compute what is x1. x1 is nothing but x naught minus f of x naught by f prime of x naught. So your x naught is minus 1, and then f of minus 1, you just have to substitute here. So this is your function, and substitute x equal to minus 1 there. So that will be minus 1 square minus 1 minus 1 divided by. So you have the f prime here. Now you substitute minus 1 there. So minus 2 plus 1. Okay, so this will be minus 1 minus. So this is minus 1 divided by minus 1, right? Yeah, so this is nothing but minus 2. So your x1 is now minus 2. Now you find x2. x2 is nothing but minus 2 minus. So you have to put f of x2. So you can see here. Okay. So this minus 2 square minus. So it is minus of minus 2, right? So no, minus 2 square minus 2 minus 1 divided by times minus 2 plus 1. Okay. So let's compute it. This will be minus 2 minus that is 4 minus 2 minus 1 minus 4 plus 1 minus 2 minus. So this is 1 by minus 3. So this is minus 2 plus 1 by 3. No, is it minus 2 plus 1 by 3 or minus 1 by 3? Yeah, are you sure you are right? Or did I made an error? So this is okay. So here you have, and then you just do. So this is okay. This is minus 6 plus 1 by 3. Minus 5 by 3. Okay. So that's all. So you just keep apply this formula. So now let's check whether this satisfies your function, which is x square plus x plus minus 1. So if you look at minus 5 by 3 square plus 5 by 3 minus 1. So this will be 25 by 9 plus 5 by 3 minus 1, which will be by 9. This is 25 plus 15 minus 9 by 9. See, if you look, it is not 0, right? I mean, whatever the number it may be. So this will be 6. I think it will be 31 by 9. If I am right. Yeah. So, but the point is, it is not equal to 0. Thing is, only with the first few iteration, you may not get a 0. You have to keep applying the iteration, and eventually you will end up getting the 0. Okay. But we are just trying to find the second one. Should be minus 5 by 3. Oh, sorry. Yeah. If I am right, so let me check once again. So this is 1, that is true. So minus 15, minus 9, so this is 10, 3. So this one by 9. Okay. Yeah. So eventually you will end up getting a 0, but maybe not in the second iteration. But one thing you can observe is so if you look at the first one, so here you look, the difference here is basically like I mean almost equal to 0.1, right? So approximately equal to 0.1. So you got like just a one digit difference you get. So you keep applying maybe 5-10 iteration, then you will get as close as you want. Okay, but not exactly the in the second iteration. Okay, I just want to tell you something also, that whenever I do a calculation, I always make error here and there. So I'm sorry about that, but I don't know how to fix that. So it was there for a very long time. It's nothing new though. Okay, so let's move on to the second problem. So here what we do is you have this function here. So I'm not telling what is the initial step, but you just substitute the formula and then you write it. Okay, so basically you want to find what is the iterative formula here. So which is you have x n plus 1 is nothing but xn minus f of x by f of xn by f prime of xn, right? So basically write in this form for this particular function. That's all. I mean, the question that I looked at has some options, but yeah. So, so if you want to write, you just have to compute what is the f prime of x. So f prime of x is nothing but 4x cube minus 2 will go away. So this is what you have. So your uh, iteration formula looks like this x power 4 minus 2 divided by 4x cube. Okay. So now you can start with any of the initial value, and then you can try to apply. You will get around, I think, 4 equations. I mean, 4 roots you will get. So when you start with a point x naught, so it will converge to some point. Let's say it converges to a root, but it will only give you one root, right? So if you want more roots, then you might have to start with some other points. So you start with the point A, and you may get one root. It will converge to a root, but you have 4 roots here, right? So you have to. I mean, I think 2 real roots, possibly 2 real roots. No, it has 4 roots here. But anyway, whatever the roots it is, uh, so what you do is if you have more than 2 roots, okay, let's say you have a function like this, okay, x minus 1 into x minus 2. So let's say you have a function like this. This is your f of x. So now it has let's say 3 roots, but if you start with the x naught, it may converges to only one of this root. Okay, so in that case, what you have to do is you probably start with another x2, let's say some let's say y naught, and it may converge to the other root. So as long as you choose the points which is kind of close enough to this, then it's most likely that this will converge to the roots that you want. Okay, so let's move on to the convex functions. But I mean, there is not much to do here, so let's move on to convex functions. So I'll just recall the definition. If for all x, oh, if yeah, so a function is convex if for all x and y. I mean, you have a function which is from the closed interval to a real number. We say this function is convex if for every x in this interval and for every lambda belongs to 0, 1, we should have f of lambda x plus 1 minus lambda y is less than or equal to lambda f of x plus 1 minus sorry plus 1 minus lambda f of y. Okay. Just 1 minute. Yeah. Okay, so this is the definition of convex functions. So I think you might have seen the lecture. So I assume that you know the geometry of what exactly this says, etc. Because I have seen the lecture and I think Sir explained it very beautifully. So uh, I mean I assume that, but essentially if we just want to recall, what it says is a function kind of looks like this. Okay. So in other words, if you take 2 points here, x and y, and if you draw the line which joins here, okay, and this line is basically lambda x plus 1 minus lambda y. So any point in the line line segment which joins x and y is of the form lambda x plus 1 minus lambda y. So what it says is, let's say you choose a point here, uh, the f of this point which is here is less than or equal to if you join. Okay, maybe I'll draw a little bit here. So let's say this is f of x and this is f of y. Okay, and you have this. Okay. So whatever the lambda you have, what it says is you take the point here and apply the f, and that has to be less than or equal to whatever the value that you come about this line. Okay, so this is also a line joining this point and not exactly this point and this point, but you have to see it here. Okay, so you see the distance here and you can see from here. Okay, but anyway, it basically says that if you join a line here and it will be kind of above your curve. Okay, if you draw the line which connects these 2 points, uh, then the line should lie above the curve. Okay, anyway, so let's move on to the problem here. So here I have a problem. Maybe I'll start with. Yeah, maybe I'll start with. Okay, maybe I'll start with this problem. It's fine. Okay. So here I have. So let's say we have two functions. Okay, we have function f and g. Both of them are convex functions, and the function f is increasing. Okay. So now the claim is the composition is also convex. So let's try here. So let's try to write the proof. So what does it means by f and g are convex function? It means that if you take for all, here I assume that f and g are function from, let's say, R to R. So f is convex. Just 1 minute. I think the conditions are, yeah, okay. So f is convex means what? F of lambda x plus 1 minus lambda times y is less than or equal to f of lambda times f of x plus 1 minus lambda times f of y, right? And we also have g is convex, so we will use that also. So g is convex. So this tells you g of lambda x plus 1 minus lambda times y. This will be less than lambda times g of x plus 1 minus lambda times g of y. Okay. So this statement we have because g is convex, right? So maybe for now I may not need the fact that f is convex, but it is that maybe yeah. Okay, I will just change the color there. Right now, first what we have is, see, we want to find f compose in G, right? So let's start with the G first. So see, since G is convex, you have this property. But now what you know is f is an increasing function. See, it does not. Okay, so if f is increasing function, then what happens if I apply the f to it? The inequality is sorry. If I apply the f to it, the inequality is preserved, right? Because increasing, so f is increasing. So this tells you that f of x1 is less than or equal to f of x2 whenever x1 is if x1 is less than or equal to x2. Right. So here what we have is let's say this is a point, okay, because this is a element in a real number and this is an element in real number. So you have 2 points here, and f is increasing. So that tells you f composition g of lambda x plus 1 minus lambda y this is less than or equal to f composition lambda g of x plus 1 minus lambda. Okay, I need to go here g of y. Okay, so this is what you have. Now you apply the fact that f is convex. So this tells you, because you have 2 points here, you have points, you have point g of x and you have point g of y, and you know that f is convex here. So this will be lambda times f compose g of x plus 1 minus lambda times f compose g of y. Right. So this is what you have. So what does this tells you? So you take this one and you take this one. Okay. So these two equation, so you kind of forget this. So this two tells you that your the f component g is a convex function, right? Okay. So here you actually need the fact that f is increasing. So without the fact that f is increasing, it's not uh, possible to do. Okay, so let's go to the next problem here. So this is the theorem that we did in the class. Uh, so the theorem says is if you have function f, which is a twice continuously differentiable function, okay, then f is convex if and only if sorry, this is f is convex if and only if the second derivative of x is less than or equal to 0 for all x. So let's okay, is there yeah, yeah, it's greater than or equal to, yeah. Sorry, the other way concave is less than or equal to, yeah. So this is good. Okay, so let's say you have the problem here. Now let's try to do this one. So you have a function which is x power 4 plus x square minus 12x minus 15. Whether we have to check whether it's a convex function or not. Okay. So let's find the f prime of x. So this is nothing but 4x cube plus 2x, so minus 12. Okay. So let's find f double prime of x. This is also so it is 4 into 3 x square plus 2. Right now the question is no, wait just a minute. Yeah. So is this always greater than or equal to 0? So that is true, right? Because whatever the x it is, here you have x square, which is always greater than or equal to 0. And you are adding 2 to this. So this term is always positive and this is always positive. So the whole term is always positive. So this function is convex. Okay. Okay, let's move on to this one. So we have also done something called epigraph, right? So if you remember, epigraph is basically so if you have a convex function here, let's say, so the epigraph is basically this region. Okay, it's basically the set of all x comma y in r square, not r, such that the f of x is less than or equal to y. So here you have f of x. I mean x comma. So it's something like x comma y, such that so basically x is here, and f of x is here. So f of x has to be less than this length here. Okay. So basically this region which is above here. So that is called the epigraph of a function. So now, okay. Now the question is the following. Suppose if my function is a convex function, then the epigraph is also convex set. So how do you prove that? So it was there in the class, so I just pick up from there. So what is a convex set means? I will just recall the convex set. Okay. Suppose let's say I have a so let's see how set like this. Okay, the set is convex if you take 2 points here and you draw the line segment which joins the 2 points x and y. Okay, so your set is convex if the line segment joining x and y is also belongs to the same set. So let's call this set as x. Yes. Then the set is convex if for all x and y belongs to the S, the line segment joining x and y also belongs to S. So in other words, you have a set is convex if for all x comma y belongs to S and lambda belongs to 0 comma 1, lambda x plus 1 minus lambda y. This belongs to your set S. Okay. So in general, on this point, so let's say if S is some subset of R2, then this point X looks like X1 comma X2, and this point Y looks like Y1 comma Y2. Okay. So whenever I just put the sign plus, that means the addition happens in the particular set. Okay, it's the addition is not a random addition, but the addition happens in whatever in the set. So assume that this set is a subset of Rn. Okay. In our case, it's basically R2, but in general, it can be Rn. Okay, so the question what you have to prove is if your function is a convex function, then the AP set is a convex set. So here I'll just repeat the statement. Let me call theorem. Let then the set is a convex set. Okay. So this is what we want to prove. So let's start the proof.
But how can we determine the line
So what we
segment
know is
joining the points?
your function is a convex function. So that means for all x comma y belongs to a real number, uh, f of lambda x plus 1 minus lambda into y. This is less than or equal to lambda times f of x plus 1 minus lambda times f of y. So this much you know, and lambda belongs to 0. But from here, you directly go to convex set is, I mean, how do you go here? So you have to start with the property that AP set is a convex set, okay? So you want to prove that AP set is a convex set, right? So let's start with 2 points in AP set. Okay, let uh, x1 comma y1 and x2 comma y2. Let's say this belongs to both of this point belongs to the epicet of y, sorry, epicet of f. So then what happens is, so you look at the definition here, the f of x has to be less than or equal to y, right? So anyhow 2 points like that. So that means f of x1 is less than or equal to y1 and f of x2 is less than or equal to y2. So this much you have. So you want to prove it is convex. So that means you want to take this convex combination and you have to prove that also belongs to your set, right? Basically, it says that line joining these 2 points has to also belongs to the set. So let's take the convex combination. So let lambda belongs to 0, 1. We don't know what the lambda is. And we take the convex combination. So it is lambda times x1 y1 plus okay. So but now you want to say this belongs to your AP set, right? Okay, so anyway, let's first simplify this. This is lambda times x1 plus 1 minus lambda times x2, lambda times y1 plus 1 minus lambda times y2. Okay, so now I want to claim that this belongs to my AP set. So that means what? F of this thing has to be less than or equal to this particular term, right? That's what we want to prove. So let's look at f of lambda x1 plus 1 minus lambda times x2. Okay. So now, okay, now what we know here, what we know is your function is convex, right? So this is what we want to kind of estimate, but what we know is our function is convex. Okay. So that means this will be less than or equal to lambda times f of x1 plus 1 minus lambda times f of x2. Okay, so how do you finish here? So this much you have, but you have to compare this with this term. But the comparison, what you have to use is the fact that this x1, this two times belongs to the episet. Okay, since this two times belongs to the episet of f of x1 must be less than or equal to y1, and f of x2 is less than or equal to y2, and we will substitute here lambda of y1 plus 1 minus lambda of y2. Okay. So if you look here, what we have got, just observe these two. What we got is f of this thing is less than or equal to basically this term. Okay, so that means this element belongs to the episet. This element is nothing but a convex combination of the 2 points that we start with. So this belongs to episet of f, and hence the proof. You have, there is a comment, right? F of x1. Yeah, exactly. So you just have to use this one and you'll get. Okay. So far, do you have any doubts? So if there's no doubt, then probably we'll move on to the next section. Okay. So we go to the next section, which is so you have doubt only in geometry part. Yeah, you can tell me what is the doubt, and I can try to explain it.
Hello, am I audible?
So maybe where is that part?
Hello,
Yeah, I have defined here. So no, you are not audible to me.
hello.
Yeah, I think, see, I think the issue is I somehow connected two devices at once. It's in the both. So yeah, I mean, it shows that your mic is active, but I was not able to hear. I don't know why.
Hello, hello, hello.
Yeah, probably, okay, maybe give me a minute. So I will just go back and join again, and maybe
Okay,
that might be audible. So just give me a minute. I will just stop the recording and then I will do it. Okay. So so let's go to the AP antiderivatives. Okay. So I think today we may not have many problems. I think it's because any problem you take, it's not very hard ones. So maybe after this we probably try a little bit hard ones. Okay. So let's try to compute the antiderivative for this function. So how do you compute antiderivative? So let me say what is antiderivative. Anyway, I'll just recall what's antiderivative. So you have a function, let's say f. Okay. Uh, let f be n function. Then so antiderivative of the function f is a function. I will just write a capital F, okay, of the function small f is the function capital F such that f prime of x is not equal to 0. Sorry, what am I writing? Yeah, f prime of x is a small f. Okay, so that is the antiderivative. Uh, so it's like going in the opposite direction. So you have f. Uh, now you can take the derivative, but then you can go the other way also, such that this derivative is f. Okay, so in that sense, it is kind of the antiderivative. Because you're not going f prime, f double prime. Instead, you go f and whatever it is, maybe much bigger f. Yeah. Okay, so that is fine. No, I will just ask question. Once you have a definition like that, now the question is, does if I give any random function, does it always have antiderivative? So, I mean, this is an interesting question because once you define something, you will always have this kind of question. Is every function has antiderivative? So, what is your guess? Yeah, yeah. You can take your time. It's fine. Okay, you are not able to start. Yeah, I will tell you something. Okay, so if suppose let's say, okay, I will probably give you a hint and you will try maybe for some time, because see there is not many people are there, only you and me are there, right? So you can take some time, it's fine. So what happens is, if you have a function and you have a antiderivative, uh, that means this is a derivative, right? So that means this, see, not every, the question is, can every function be a derivative? That's exactly what is happening, right? So derivative means, can you come up with the property of derivative, uh, which may not be true for, so basically you prove like that. If you have a function, let's say you have function f, and then you compute f prime. Let's say this is a differentiable function. You compute f prime, and then kind of give a property for this f prime. So if you give a property for f prime, then you can always okay, think whether it has a, so instead of finding the derivative, you go this the derivative implies something, okay, and then check whether your function, I mean every function has this property. Sometimes it's easy to see that way. I mean, hey, by the way, I just have to tell this, we have not done in the class, so yeah, exactly. So that is exactly the thing. So this is we have not done in the class. So just telling. So what you have is but we have done in the tutorial. So, but I didn't give the proof though. I just said it a while ago. So if you look at the derivative, so what we know is the derivative has implies the intermediate value property. So in other words, if you want to look at the exact theorem, I mean, instead of writing implies intermediate value property, I will just write the theorem here. So directly. Which says that let I belongs to R be an open interval. Then if I mean I'm just writing the intermediate value property here, nothing much, belongs to I with the x1 less than x2 and y lies between f prime of x1 and f prime of x2. So if you have all this property, then there exists x belongs to x1 x2 such that I mean this is not a point, this is not a tuple, this is a I mean interval interval x1 x2, okay, such that f prime of x is equal to y. Okay, basically it's the intermediate value property and here you just have to take the open interval, okay. I mean that's the only thing, it's not anything new. Okay, so if you have a derivative, if your function is a derivative, then it satisfies intermediate value property, but not all the functions have intermediate value property. So can you give a function which does not have intermediate value property? This also I think we might have done, if I remember correctly. So maybe you can draw here. Let's say I think I can draw a function like this. It goes like this. Let's say in 0 also it is, let's say -1. And here everything is 1. Okay, this function does not have intermediate value property, right? And if you have a derivative, this function cannot be a derivative. Okay, so in other words, if you want to look little bit further, so if you have a, function which is let's say differentiable, then the derivative need not to be continuous. Okay, so derivative has intermediate value property, but it need not to be continuous. So this does not mean continuous. But what you can do is it can have discontinuity, but it cannot have a jump discontinuity. Okay, because if you have a jump discontinuity, which is a jump discontinuity like this, then what happens is see this function is not does not have intermediate value property, right? And it cannot be a derivative. So if you have a derivative, it does not have a jump discontinuity. So derivative also implies basically the intermediate value property. This will tells you uh, cannot have a jump discontinuity. But anyway, this is not useful for now. But I'm just telling cannot have. Okay, so let's go to the problem here. Okay, so you have function and you want to find the antiderivative. Okay, so the easiest way to find is you just take the derivative of this and check which one satisfies the property. Okay, so that's what we are going to do. So let's take the first one and take the derivative of this. Let me call this function. Let me call this function as f. This is g and this is h. So if you look at f prime, this is nothing but 1 by 2 2x plus. So this is basically x power minus 2, and so if you take the derivative, that will be minus 2 into uh, x power minus 3, which is okay, whatever it is. If you cancel it, you will not get this, right? So this is not same as that. Okay. So let's look at the second one. Second one is also similar. So let's look at the g prime. This will be 2 by 3 and 1 plus minus 1 power 1 by x square. So if you look, and this is also not equal to whatever the function. So let's look at the third function. So this will be 2 by 3. So let me just write what is h first. Uh, X power 2 by 3 plus 2 times x power 1 by, no, this is not 2 by 3, this is 3 by 2. Yeah, 1 by 2. So this is your function. So let's take h prime and 2 by 3 and then 3 by 2 you will have, and then x power 3 by 2 minus 1 plus 2 by 2 x power minus 1 by 2. So this is what I have, I think, yeah. So this will get cancelled. This terms will get cancelled. So this, and this is x power. This is 3 minus 2 by 2, which is 1 by 2. Plus x minus minus 1 by, sorry, yeah. So this is what you have, and this will be nothing but the square root of x plus 1 by square root of x. Okay, so this is what you have. Okay, so the third one is the correct one, and the rest of the things are not antiderivative. Okay, so these are correct and these are wrong. By the way, just I see, I told you that this is not equal to this, uh, but I mean, the reason is, I mean, it looks differently. I mean, this will be 2x and something else. But if you, whenever I want to say two functions are different, that means either the domain is different, or you have f of x is not equal to g of x. Okay, so then only you can say two functions are different. So if you want to claim, okay, these two functions are different, you actually have to produce a x such that uh, this f prime of x or whatever it is, and this is not equal to sorry, I should not call this as f, right? So I call this as a h. Okay, I don't know what's let's say I call it as r. Okay, I'll change it to r. Okay. Okay, so basically you have to find a x such that r prime of x is not equal to f of x. Okay, so I mean I hope you can find one x. Okay, So, I mean, it's easy to see these are different, but I just want to tell you that, I mean, just because it looks different does not necessarily means that the function is different. Most of the time it will be different, but not necessarily always, and we may not know for sure what happens. So, it's better to find x such that r prime of x is not equal to f of x. But I just skip that part, okay? So you can choose a random x and see if it works or not. Okay, so let's move on to next question here. So the question is very simple here. So what I have is I have a g of x, okay, and g of x is an antiderivative of f of x. So the question is g of x plus 2 is also an antiderivative of f of x. Okay, so of course the answer is simple. Mm, just give me a minute. Yeah. So so that means what? Since g is an antiderivative of f, that means f prime of x is equal to g of x, right? So this is because g is antiderivative. Okay, but the claim is whether g plus 2 is also antiderivative. So basically, what you have to do is oh sorry, I think I wrote it wrongly. G is antiderivative means g prime of x is equal to f of x. Okay. Okay, so then question is whether this is the antiderivative. That means you take the derivative of this. So what is the derivative of g of x plus 2 whole prime? So the derivative of this is nothing but again it's g prime of x. I mean derivative is additive and the derivative of the constant is 0. So this will be 0, but this is nothing but g prime of x. But we know g prime of x is antiderivative, so this is g prime of x is nothing but f of x. Right? So if you put any constant here, I mean, it does not matter whether it's a 2 or 3 or whatever the constant you put, still the derivative will be the same. And so this is also an antiderivative. So now what we have seen is if you have function and I mean, so if you have function g of x and you just add anything to it, these two things are still antiderivative, right? So basically, if you have g, which is antiderivative, then g plus a for any constant a is also an antiderivative. So now one can ask the converse question. Suppose if you have two functions, let's say g1 and g2, such that f of uh, such that g1 and g2 such that g1 prime is equal to g2 prime. So now the question is, does that means g2 is nothing but g1 of x plus some constant? So you can try this. This is I mean, it may not be hard, but yeah. So how do you prove it? We'll use mean value theorem. Okay. Hmm. Okay, how do you use the mean value theorem? Okay, so yeah, okay, good. So you got the idea. So let's write the proof. Proof is simple. So I will follow. Okay, probably you will type. I will just follow and check whether it's true. So what you have is uh, G1 prime. This is equal to G2 prime, right? So this implies G1 minus uh, G2, the whole prime is 0. Yeah, so this is equal to 0. So this is G1 prime, G2 prime. Yeah, this is equal to 0. And from here, what you do? How do you know? Okay, there you have to use the Minimalist theorem. Okay. Okay. So basically, I mean, you forget whether it's G1 or G2. So basically, what you have is you have a function f. Okay, you have a function which is I mean differentiable function. Let's say such that f prime of x is equal to 0 for all x belongs to R. Okay, now the claim is what can you say about f? Okay, so let's see. So he said we use mean value theorem. So let's use mean value theorem and see. Okay, let a comma b belongs to R. Okay, or maybe we can fix this A and then let's say we move the B, but it doesn't matter. So let's fix this part. Okay, so by mean value theorem, what you know is f of A minus f of B by I mean, yeah, f of b minus f of a, whatever you want to do, it doesn't really matter, I think. Does it matter? Anyway, we will do f of b minus f of a. It doesn't matter. F of a by b minus a. This is equal to f prime of c for some c belongs to okay. So I mean, it depends on whether A is greater than B or A is less than B. This inequality changes, but it doesn't matter. Whatever the inequality is, what we know is this is 0, right? Because that is what we have here. Okay, so this will be equal to 0. So that means you can take this to the other side, and that goes away. So what you have here is f of b is equal to f of a. Okay, and this is true for any a and b, and in particular if you want you can fix a, so call that f of a is equal to c, then you can vary over any b, uh, and whatever the b f of b is also equal to c. Okay, you can just it's a simple application of mean value theorem. So that tells you that if your function has derivative 0, then the function is constant, then f is constant. Okay, so here what we have is if you have two derivatives which are equal, uh, then the derivative of the difference is 0. Since the derivative of difference is 0, the function is a constant. So that means g1 is g1 minus g2 is some c or a. Let me call it as a. So g1 equal to g2 plus a. Okay. So if you have two antiderivatives, uh, then they are basically differ by a constant. Okay, so that is the okay. So let's move to the next problem here. So here you have an initial value problem. So what does initial value problem means? So it's a equation. Okay, first of all it's a differential equation. So differential equation is a equation which involves the derivative and whatever the function you have. So it's a function as well as I mean it's a function as well as the derivatives are involved. Okay, and these are the differential equation. It's an ordinary differential equation. It's called because there's only one variable. So you have a function like y equal to f of x. Okay. Now you want to by solve the differential equation for means that you want to find y. Okay, so that is what it says, find y such that these two conditions happen. Okay, so that's a such that y prime equal to 2x and y of 2 equal to 3. Yeah, why do you want y? I mean, it's called initial value problem because at some value it is given. So this value you can kind of see it as an initial value. So this is called kind of the initial value problem. Okay. You will see why we needed it, but let's try to find it. So what you want to find is find a function y such that if you take the derivative, it will be 2x. Okay. So what we know here is if you so far we are not doing the indefinite integral we haven't done in the class. So I mean, if you have done mathematics in the 11th and 12th, then you know what is the integral of this. But since we have not done in the class, I will not use any of those formulas. So what we know is if you take the derivative of x power n, uh, if you take the derivative of x power n, you will get n into x power n minus 1, right? So here you want to find a function y such that the derivative is 2x, right? So from here you will kind of try to do it. So you have to compare these two. That means kind of the n is like 2 here, right? And that means whatever that has to come in the top, uh, this has to kind of matches with that. Okay, so what is the function here? I mean, it's not necessarily n. I mean, you can have something like that. You can have a alpha times x of n, right? It's not necessarily n. Yeah. So if you want x, then your exponent has to be 2, right? Only then you will get x here. So this has to be x square, then y has to be x square. But then if you take the derivative of y, yeah, that will be 2x. So you take the y prime, that will be 2x. So you have that. Okay. So your function is basically x square. But in general, what happens is the antiderivative, we just see the antiderivative is differ by a constant. I mean, this is one antiderivative. But if you apply 2 to it, if you see, check the y of 2 here. Uh, y of 2, this is basically 2 cube, 2 square, this is 4. And this y of 2 is not equal to 3. So this function does not satisfy this particular problem. But instead what you do is, this is one antiderivative. So you know how all the other antiderivative looks like. So all the other antiderivative looks like the following. Y is equal to x square plus some constant a. Okay, so now what I need is I have initial value which is y of 2 has to be equal to 3. So let me substitute y of 2 which is 2 square plus a, and it has to equal to 3. That means we compute a equal to minus 1. So the antiderivative that you want is y equal to x square minus 1. Okay. So even though your antiderivatives are not unique, given that initial value or given one value here, you can find it uniquely. Okay. So basically, what it tells you is the following. So if you see here, so this is one antiderivative. Every other antiderivative is differed by a constant, right? So that means if you draw all the antiderivatives, it looks like okay, this is one antiderivative. Another antiderivative is kind of above, something like this. Okay, so it is the same function, but you just translate it above. Okay, and you can translate it below also. So you have the families of function like that. But if I know, okay, at this point, what is my function value? Let's say at this point it says 1, my function value is 1. Okay, and then this is the only curve that has that particular thing. Okay, so that is what we are trying to do. Okay, so let's move on to the next question here. Just give me 1 minute. This is the okay. Yeah, I don't have many problems left, so let's try this, and probably will bring up a few more problems. So here I'm not going to do the problem because it's from your assignment, so I'm not going to do that. But I'll just give you the hint. So if you have a problem like that, then how do you proceed? So basically, it says you have to find the value of x such that these two functions are same. So what do you do here? So the idea is you take it to the other side. Okay, so this is basically equation. You have e power minus x square. So I'm just giving the hint. I'm not giving the solution. So this is equal to x square minus x plus 1, right? So you take to the other side, that will become minus x square plus x minus 1 equal to 0. Okay, so this is the function you have. Now what you are going to do is, so you have function f here. So what you want to find is find x such that f of x is equal to 0. Okay, so this is what you want to find. Uh, okay, how do you find it? You basically apply the Newton-Raphson method. Okay, so the hint is to apply the Newton-Raphson. I mean, apply the Newton iteration method. Okay. Okay, so let's do this problem here. See, I'm not going to prove this anyway, so I will leave it here. So I'm just give the hint so you can try. So we'll do the find the total area. Between the region y equal to let me write I mean I will write a small function. I will not write much. Okay, x cube plus 4 0 less than or equal to x less than or equal to 2 and the x-axis. Okay. So you have to find the area of the curve. Area of okay, I will draw it here. So first, whenever you have a problem like that, you try to draw. I mean, it's not always easy to draw the function. I mean, I also don't know how it looks like, but it looks something like this. Okay, let's see here. And at 0 it will be 4. So here, let's say I have 2 here. Okay, so you have to find the area which is bounded by this curve, which is here, and you have the x-axis which is below, and on the side by these two numbers. Okay. So if you want to find the area of the curve, which is basically means you are going to take the integral, right? So this basically follows from the first fundamental theorem. So this area of this curve is nothing but you take the integral of y dx bounded by the area 0 and 2. Okay. Okay. So this is what you have. Okay. Now let's compute this integral. So this is nothing but integral 0 to 2 x cube plus 4 dx. So if you know how to integrate, you might have the direct formula. If you don't know how to integrate, then you find the antiderivatives. So the antiderivative is not here. I think it will be. So I will write here, but you can find the antiderivative. So this is x power 4 by 4 plus 4 x square by 2. Yeah. So not this. Yeah. So this is the antiderivative. 4x. Yeah, 4x. Yeah. Sorry, not x square. Yeah. Yeah. This just 4 is the rate, not yeah. Okay, and if you want the formula is basically if you the integral of x power n dx. This is nothing but x power n plus 1 by n plus 1. Okay, so if you want to use it, I mean, we haven't done it here yet, I think, but I mean, if you want, you can use it. That's fine. Most of you might have already done it. So you just substitute the value here. So if you substitute the value, you'll get 2 power 4 by 4 plus 8. And when you apply 0 to it, these two terms are 0, so this will go away. So what you get is 4 plus 8, which is 12. Okay. Yeah, so your answer is right. Okay, so this is fine. So let me give you another problem here. So let's say how do you find this one? But I have to uh, get a correct function. So give me a minute. I probably try to get a correct function. Okay, I'll draw the probably I'll draw it here. Okay, so okay, let's say I have a function like this. Okay, so let's say this function is y equal to x square. Let's say, and I have another function here. Okay, let's say this is y equal to minus x square plus something. Let me put a 2 here, or I can put 1. Okay. Now I need to I want to find the area between this thing. Okay. So how do you find this? Okay. So to find it, what first you have to do is you have to find what is this intersection point, right? So once you find this intersection point, which is this, you have to find what is this intersection point first. So let's find the intersection point. So the intersection point has to satisfy that x square is equal to minus x square plus 1. So that in other way it means that 2x square is equal to 1 by okay 2x square equal to 1. Okay, maybe I'll change this number. I'll just tweak this number so that the computation is easy. Otherwise, it's the same idea. Idea is same, but your computation will be hard. So I'm just making my life easier. I don't. Yeah. To avoid doing the computation, I'm just doing like this. But whatever comes, the idea is kind of the same. Okay. Even this might not help me, so maybe I'll put 8 here. Sorry about that. Okay. See, otherwise, what happens is you might have to take the cube root. I mean, some square root you have to take. I mean, I don't want to work with the square root, but That's the thing. But one can do it. It's just that I want the idea to be clear. Not that I want to make it so many competitions. So what matters is the idea. Okay. So if you find x, that is basically 2, right? It's basically plus or minus 2, uh, but this point is 2. So now if you want to find the total area, so what you do is you find the whole area here and then subtract this area. Okay. So if you find the total area and let's say you subtract this area, this region which is in the blue, okay, then you got the region which is in the red, right? So this is what you have. So if you want to find that what is the total area, so the total area is nothing but, okay, maybe I'll erase this. I'll write x equal to. Okay, so the total area is nothing but the integral 0 to 2 minus x square plus 8 dx. Okay, but I want to subtract the area bound by this curve, right? So this area I want to subtract. So that is minus integral 0 to 2 x square dx, right? So if you have two curves like that, okay, if you have curve f and curve g, and you want to find the area, basically you are going to find integral f of x dx. Okay, so which is what I'm going to find. So this, and see, we have done in the class that if you have integral of a function f and g, that is nothing but integral of f plus integral of g. Okay, so this is equal to 0 to 2 minus 2 x square plus 8 dx. This is equal to, okay, this minus 2 x cubed by 3 plus 8x 0 to 2 equal to minus 8 uh, 2 times minus 8 and 3 plus 2 times 8, so that is minus 16 by 3 plus 16, which is, I think it is equal to 32 by 3. If I am right, it is 32 by 3. Okay, so if you want to find the area, so this is basically how you find it. Okay, so if you have two curves like that, and let's say it is intersecting, and you want to find this area, then this is how you find it. Okay, suppose if I have uh, instead of this, let me take the same diagram, uh, and we will just change it a little bit and then find it. Yeah, it is still recording, so that much is good at least. So it's recording is not gone. Okay, so we have the same diagram. We will just modify it a little bit. Now, okay, I think it's not modifying. Okay, how do I do it? Okay. So now let's say I want to find the. I mean, I have the same diagram, but I just want to find this area. Now, how do you find it? So here, what you do is, I mean, it's the same problem, right? So some of the things that we already know, which is we know the intersection here, which is 2, and we also know this area of this part we know. This part area is basically 32 by 3, so which we know. We just need to find this area, right? So let's zoom in and we'll just edit it a little bit. Need to get a standard result. And let me call this as area 1, and maybe call this as area 2. Okay. So I have two areas here now, which is area 1 and area 2. And my whole area is just the sum of this part and this part. Right, and A1 we already calculated. So let's calculate the A2. The A2 is nothing but integral. You see, you look, it is by this region, right? So you have to take this curve. Integral 2 to, okay, we have to find what is this point. This point is where y is 0, so this has to be equal to 0. So I want to find this point. So let's find that point and then we will proceed. So that point is where y, okay, let's say this is, okay, anyway. So that point is where x square minus x square plus 8 is equal to 0. That means x square is equal to 8. So x is equal to 2 root 2. Yeah, I mean, I don't want to take the root, but finally we end up with the root. Okay, so this point is 2 root 2. So now what you do is you find the area of that. So A2 is nothing but integral 2 to 2 root 2. Okay, I think that is right, right? If you take the square, I will get 4, yeah. Minus x square plus 8 dx. This is nothing but minus x cube by 3 plus 8x. And I need to evaluate at 2 to 2 root 2. And this will be x cube of that, right? And that will be 2 cube is 8 minus 16 root 2 by 3 plus 16 root 2. Okay. Now this, and then you have to subtract. So whenever I write like that, it means so whenever I write f bracket let's say ab, that means f of a minus f of b. Okay. So that's the notation means. So minus that is 8 minus 8 by 3. Okay. So you have the answer, right? So let me check it. Okay. I will add the comments. So it's minus 8 by 3 plus 16. Okay. Well, you have to simplify this. Uh, but let's say we'll just skip the simplification. Okay. So you have square root of 2, right? Yeah. I'll skip the simplification for now. What we computed is the A2, which is the area here, right? But I want the total area, which is this region. Uh, Now I break it into two pieces. This we have already computed, which is 32 by 3. And this region A2, which we have computed now, which is basically this part. So your total area, which is A1 plus A2, which is the required area. Yeah, I mean, it may not be very wrong. I mean, you might made a little bit error from simplifying it. Or, I mean, so that's why I'm not trying to simplify now. Which is basically this area is 32 by 3, which is the area A1 here. So, which is 32 by 3 plus whatever this number is. Okay. So, yeah, I will call this as A2 plus A2. Okay. So, this is the required area. So, I mean, I'm not doing the computation here. I mean, computation is just the simplification I'm not doing. Uh, but the idea is whenever you want to compute the area which is let's say complicated like this, and which is kind of bounded by, so you have these two curves and you want to find the area which is lies something along here. So what you do is you basically split the areas, find this as under this curve, and find this area. This is basically, it's a different curve, right? So when you want to find this area, you have to look at this curve. But when you want to find this area, you have to look at this particular curve. Okay, it's a different curves. If you want to find this area, so that basically means, let's say I call this as 1 as f and 1 as g. We call this f of x, and if I call this as g of x, and I want to find this area. This area is nothing but this one I probably draw here. This is nothing but integral g minus f of x dx. And the range, you have to find the intersection point, whatever the point is. In this case, it's 0 to 2. This is 0 to 2. Okay. So that's the idea. You just split it, and then you find the areas. Okay. It depends on whatever how the region looks like. The things will change. It need not be exactly g minus f, but depending on that, you can able to do. Okay. So probably you can draw a more complicated picture, and then you can try to find okay whatever it is. So if you want, you can add another line here. Okay. So if you want, I can add. So let me add another line here which pass through here. Okay. So maybe draw in a different color here. Okay. And let's say my so this is y equal to x square. So that is a black line. And let's say this is y equal to 2x. Well, now I can also ask you, okay, what is the this particular area? I mean, I can ask you, okay, what is this area? Okay, so or yeah, it's the same thing, right? You take this curve and this line. You will not take this curve into picture. Okay, this is the worst color to write. Okay, anyway, depends on the problem. You just look at the geometry of it and kind of split it into different regions, on each of which where you can able to compute easily. Okay, so that is the idea, and by doing that, you can get more or less you can get what you want. Okay, we'll just look at the time. We can do one problem. I'll just check if there is any good problem. Otherwise, we can meet some other time.
Sir, good evening, sir. Sir,
Yeah, I think more or less we have covered most of the things that might come in the class. I think.
sir,
Yes. Okay. Yeah, we more or less covered everything. Probably I'll just tell you little interesting things. See, if you look in the history, right? Whenever we are doing the in the class, what we are doing is the other student is speaking. Oh,
sir.
okay.
My,
Yeah. Could you just give me a minute? I think my mic is not audible here. I don't know why. I will join with other account so you can speak. Okay. Can you speak now?
yeah, good evening, sir.
Yeah. Hello.
Sir, actually, I have a doubt on the fourth week assignment problem. Actually, I don't understand the question, sir.
Yeah. Which
Um,
question?
yeah, the question is the maximum value of the function of two variable is given on the line. One constraint is given.
Okay.
So, the question is they are asking the maximum value. I understand that, uh, um, which means I have to find. Um, Actually, I search how to do that problem like that. So I find I have to find a del f, and that is parallel to the del of that line.
Could you tell me what problem it is so that I can also take the problem? It's a fourth
But
week.
fourth week, actually, it is a assignment problem, sir. Um,
Assignment, but what's the
uh,
problem number?
Problem number fourth problem.
Fourth problem is some antiderivative, right?
No, it's week.
I'm sure it's fourth week or
I'm
third
sorry.
week.
I'm sorry, sir. Actually, I thought it is the calculus of several variable. I'm sorry. I'm sorry.
Yeah, yeah, okay, okay, okay.
For that, the calculus of several variables, will they conduct this kind of online session, sir?
I think they will contact you. If you want, I can just check and tell you. But I think they will
Actually,
contact.
no, sir. Actually, it doesn't show anything below the week assignments. No
Oh,
recorded video is there.
but is the several available courses offered? No.
Yes, sir. Offered, I've applied for exam also.
Okay. Then
But
it may-
there is no online sessions like this. They are conducting for that. I thought you're the one also conducting for that. That's why I asked the question.
no, we are just doing the one variable calculus
One
here.
variable. Oh, okay, okay,
But
sir.
I think for the several variable there is no tutorial. I think.
Yes, sir.
Yeah.
Yes, sir.
I was able to see the all the tutorial seats, but it is not there. So yeah.
Yes, sir. Yes, sir. Okay, okay, okay.
Okay. Probably
So, like,
nobody would.
okay. If, like this assignment questions, the same way I'll have a questions on the exams, right? Or they will ask questions like descriptive or MCQs only.
Oh, okay. See, the one thing is, I never attended the exam. Okay, so I
Oh,
don't
you
know
don't
for
know?
sure. I don't
Okay.
know for sure, and also year to year they may change it. But
Okay.
one thing I can say is it's not necessarily MCQ.
Okay.
Because the reason is when you want to do the assignment, we want to evaluate, right? When you
Okay.
want to evaluate, ideally we like to be MCQ, so it will be easy. So if
Okay.
many people are applying, it's most likely there will be more MCQ.
Okay.
But if there is only, let's say, 10 people are writing the exam, and maybe a faculty may be interested in correcting, then probably some of the question may come. But I don't know for sure. So more or less, you can expect MCQ.
Okay. But it is CBT, right?
What is CBT?
Computer based. Written means how will I write?
Okay. See, I don't know for sure. Maybe I can ask somebody, verify, and then let you know. That
Yeah.
would be
Okay, sir.
suitable.
Ah, okay, sir. Okay.
So maybe I will send you my mail ID, so you can just
Yes, sir. I'll ask you
Send
in
me a
mail.
mail. I
Uh,
will ask somebody and then let you know, because I
yes,
don't know for sure. I don't want to say something which I don't know.
yes, sir. I'll ask you in mail.
But yeah,
Uh,
I will
yeah.
let you know.
Yes. Thank you, sir.
Yeah. Okay. Okay. Then we will probably stop now. So I will log out from here. Yeah, I joined again. So I was telling something, but yeah, I was not able. But anyway, I mean, I mute that mic. So okay. So what is your doubts anyway? I'll go to the screen.
Yes. I tried solving one problem. Can you please verify my solution?
Yeah. You will give me the problem. I can try to. Or if you have the screen that you can share.
Uh, I will speak the problem.
Uh, like you will say the problem. That's what you're telling. Yeah. Okay. You can tell
Yes,
me the
and the
problem.
solution.
You'll send the solution where?
Okay, so no, sorry, I will speak.
Okay. You let me know. I can write here. Yeah.
Okay, so uh, d dash x is not zero for all x in open interval AB.
Can you repeat again?
So G is a differentiable function
Okay. G is a differentiable function.
and g dash x is not zero for all x in AB, open AB.
Okay.
So we have to prove that GA should not equal GB. So I know you can prove it by Rolle's theorem, but I have another way of solving.
Okay.
So G dash x is not zero means G dash x is either greater than zero or less than zero.
Yeah, that is true. Let's write the proof. Okay, g dash x is not equal to 0. That means g dash x is greater than or equal to 0, or the x is less than or equal to. See here, I mean, you have to use this intermediate value property of the derivative. Then you can prove it is greater than or
Yes,
equal to 0. If it is greater than or equal to 0, then it is greater than or equal to 0 for all x, right? You want that much stronger, or you don't want that?
no, I proceeded in a different way,
Okay, you let me know. Yeah.
but I used the intermediate value property.
Okay. So this is greater than or
So
equal to 0 for all x belongs to whatever the interval r. Okay, and then
yes, here only I have problem. Here you split the for all operator, right,
yeah.
over the or.
Yeah.
So uh, So I just wanted to check that the way I split it is right or wrong. First,
So how
I
you split
assume
it?
that for, uh, I assume that g dash a is greater than 0 and g dash b is less than 0 for some a and b.
I mean, not A and B, but some X1 and X2, let's say.
Oh, sorry. Yes.
Yeah. I mean,
So
some 2 points.
by the intermediate value property, g dash x will be 0 for some x.
Yeah, that is true. Yeah.
So then does this give us enough justification for splitting the for all operator?
Yeah, it will give justification, enough justification, right? Because if it is not for all x belongs to a b, that means there exists 2 points. So you proceed like that. So you want to prove, you assume this, you want to prove this statement is true, right? So this is the R statement, and you want to prove an R statement is true. That means, so if you want to prove R statement is true, the one easy way is to assume one of that is wrong, and then you prove the other one is true. Okay, let's assume that this is false. Now you want to prove this is true. Okay, so let's say this is not true. Okay, that means g of x is okay. Maybe see, I can do whatever I want, but I think you might follow your way, right? And probably you will stick with that rather than I telling my idea. So your question is just give me a minute. I will take a minute to understand. Your proof is right. There is nothing wrong with that. Basically, you have to go via the contradiction. That's all. If suppose this statement is not true,
Yes.
okay, I think eventually you will come back to that only. So basically, you want to prove the statement, right? The proof that you went is via the contradiction. That means if the statement is not true, then the negation of the statement is true, which is this is false, also this is false, right? Or in other words, what you can prove is assume this is false and then you prove this is true. Okay, so now this is false, ignore it. So you want to prove this is true. Suppose this is not true, then what happens?
Like if you have for all x p of x
Hmm.
or for all y q of y. No, sorry. For all x q of x.
Hmm.
Right. This is we have to prove. So we assume it's negation. That is, there exists x p of x and not p of x, and there exists x not q of x. Something like that.
See, the statement goes like this: p of x, I mean for all x, p of x, comma, or for all x, q of x, right? So the negation of this
Yes.
statement is nothing but there exists x, not p of x, right?
Yes.
And there exists x, not q of x. And this creates you a problem.
So what should I assume? I should assume that g dash x is less than equal to 0 uh, and it is greater than equal to 0 for some
Yeah. So it
value.
is basically, if you look at the negation, what negation tells you is there exists x1 such that g prime of x is less than or equal to 0, and so here you have and here, and there exists x2 such that g prime of x2 is greater than or equal to 0. Okay, so this is what the negation tells you, but you already know from the hypothesis that g prime of x is not equal to 0, right? So
Yes.
you with this also, what you get is So now this is just a negation, but now you have to use your hypothesis because you have the imply statement, right? So this statement is true. So that by itself means there exists a x1 such that g of x1 uh, is strictly less than 0, and there exists x2 such that g prime of x2 uh, is strictly greater than 0. So basically what happens is you want to prove this statement, right?
Yes.
Uh, prove this statement. What you prove is the negation is false. If you look at the negation, this is the negation now. Now you want to prove this negation is false, right? But what you know is this is true. Okay, so let's assume this negation is true. If the negation is true and this statement is true, then let's get a contradiction. That's what you're going to say. So we got the negation is true, and since this statement is also true, you end up with this statement. Now from this statement,
So
you
this
have the
is
proof,
what
right?
I assume.
Uh-huh.
So yes, this is what I assumed, that
Yeah,
g dash
exactly.
x1 is less than 0.